Statistics lesson 5.2, binomial probability distribution. Describe a binomial probability distribution and find probability values for a binomial distribution. The second objective is compute the mean and standard deviation for a binomial distribution. Then use those results to determine whether results are significantly low or significantly high. Also, binomial distribution, this binomial distribution is actually one particular category of the discrete probability, okay? There's others, but we're only going to study the binomial today. A binomial probability distribution results from a procedure that meets these four requirements. The procedure has a fixed number of trials. The trials must be independent, meaning the outcome of any individual trial does not affect the probabilities in the other trial. Each trial must have all outcomes classified into exactly two categories referred to as success and failure, and the probability of success remains the same in all trials. Now, there's some notation that goes with this, and I'm gonna have to let me put this notation. We've got there's some notation. N is the number, the fixed number of trials. There's also X, and that's the specific number of successes in N trial. Specific. You also have P. P is the probability of success. That's terrible. Of success in one of the N trials. Q is the probability of failure, and it's usually 1 minus P, or it's always 1 minus P. That's the probability of failure. Probability of failure in one of the N trials. P of X, you'll see that a lot. That's the probability of getting exactly X successes among the N trials. All right, that's the notation you need to be concerned with. Example, when an adult is randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. And this is by the Pew Research Center survey. Suppose that we want to find the probability that exactly 3 out of 5 randomly selected adults know what Twitter is. To do that, we need to make sure that we can use a binomial probability distribution. So the first requirement, the number of trials. In this case, it's 5. It's fixed. That was the first one. The second one, 5 trials are independent because the probability of any adult knowing Twitter is not affected by results from the other selected adults. So 2, the 5 trials are independent. 3, each of the 5 categories has 2 outcomes, or 2 categories of outcomes. Each of the 5 trials has 2 categories of outcomes. I'm about to spell the outcomes. They either know or they don't know. And then the fourth, for each randomly selected adult, there's an 85% probability this person knows what Twitter is. So that's a fixed probability. There is a fixed probability. It's the same for everybody. Everybody. All right, so now that we know that it is a binomial distribution, what is n? Let's see here. N equals 5. X equals 3. P equals 0.85. And Q equals 1 minus 0.85, which is 0.15. So those are the variables. So when selecting a sample, we usually sample without replacement. Sampling without replacement results in dependent events, which violates a requirement of a binomial distribution. However, we can often treat the events as if they were independent by applying the 5% guideline for cumbersome calculations. When sampling without replacement and the sample size is no more than 5% of the size of the population, treat the selections as being independent, even though they are actually dependent. Methods for finding binomial probabilities. And there are several methods. The first is the formula. P of x equals n factorial divided by n minus x factorial times x factorial times P of x times Q of n minus x. Okay. So suppose we want to find the probability that exactly 3 out of 5 randomly selected adults know what Twitter is. So we set the equation up. P of 3 is 5 factorial. And then we're going to have 5 minus 3 factorial. And then 3 factorial times P is 0.85, 0.85, and then 3 to the third power times Q, which is 0.15 to the 5 minus 3. Okay, let's try that in our calculator. And you can see I've already tried it a little bit, but anyway, so control divide. We have 5 menu 5 1 over open parentheses 5 minus 3 close parentheses menu 5 1 times 3 and then menu 5 1 3 factorial and then times open parentheses 0.85 close parentheses caret 3. Then you got to make sure you see how that line got long. Now you can times and 0.15 close parentheses squared. So it's 0.138 equals 0.138 or 0.138. So there is a 0.138 that we're going to get 3 randomly selected individuals. That knows what Twitter is. And the second method is technology. We're going to use the formula n choose x times p of x times q of n minus x. So in this case, it's going to be 5 choose 3 times 0.85 to the third times 0.15, and 5 minus 3 is 2. Okay, so let's try that. Menu 5 3, and then we got 5 comma 3 close parentheses times open parentheses 0.85 caret 3 times 0.15 close parentheses squared, and we get the same exact answer. Equals 0.138. Now, there's actually another way we can do it. Okay? And this one is actually even easier. Let's go to the calculator. And we're going to do menu 5 5A down here, binomial PDF. Number of trials, 5. Probability of success, 0.85. And then the x value we're looking for is 3. Same exact answer. All right, so this method here is menu 5 3. And this other method that gives you basically that is menu I don't know why I put it. Menu 5 5A. All right. Might want to put those in the notes. Makes things much easier. Okay. Here's another one. The NFL changed the overtime rule in 2012. Between 1974 and 2011, there were 460 NFL football games decided in overtime. 252 of them were won by the team that won the overtime coin toss. Is the result of 252 wins in the 460 games equivalent to random chance, or is 252 wins significantly high? Let's try it. So the probability that X is greater than or equal to 252, okay? That would equal the probability of 252 plus the probability of 253 plus the probability of 254 plus so and so on, plus the probability of 460. Boy, that would be a cumbersome calculation, okay? Cumbersome. All right, so technology will help, and we're going to use menu 55B. All right, menu 55B. So let's go in here, menu 55, and then it's called menu 55, and then, like I said, it is called Binomial CDF or B. Number of trials, 460. Probability of success, 0.85. The lower bound, 252. The upper bound, 460. And that gave, oh, no, I shouldn't, it wasn't 0.85. I got that confused with the other. It's 0.5 because heads is one, tails is the other. So 0.0224 is 0.0224. Now, is that significantly high? Well, we go back to our test. Significantly high. If the probability of X is greater than or equal to 252 is 0.05 less than or equal to, then it is significantly high. All right, and 0.0224 is less than 0.05, so it is significantly high. So it's kind of important that you want that coin toss. Now they don't do that anymore. They got a different way of doing it, but anyway, that's what they used to do. All right, folks. Good job. See you in class. Have a wonderful evening.